You can do every line of the calculus correctly, arrive at the right number, and still score nothing. That happens in this one topic more than anywhere else on the paper, and the reason is almost silly. The question asks for a line. A derivative gives you a number. A number is a direction. It tells you which way to point, and it tells you nothing else at all. Every one of these lines has gradient too. There are infinitely many of them, and no two of them are the same line. One thing separates them, where they are. So a line needs two pieces of information, a direction and somewhere to be. The derivative hands you the direction. The curve itself hands you the position. That is the whole of tangents and normals. Put those two things together twice. Once along the curve, and that line is called the tangent. Once at right angles to it, and that line is called the normal. By the end of this, you will have a full exam question worked, with the 7 marks shown where they are actually awarded, and 3 checks that catch a wrong answer in a few seconds each. Start with the tangent, and start by memorizing nothing. The gradient of a straight line is the rise divided by the run, measured between any 2 points on it. So take the point we already know, and any other point on the line at all. The rise between them is the difference in height. The run is the difference across. Rise over run equals the gradient. Multiply both sides by the run, and there is the formula everybody quotes. It is not a new fact to learn. It is the definition of gradient with the fraction cleared away. Now the gradient itself, and here is where marks go missing. Differentiating gives you a gradient function. It is a rule, and it still has an x in it. The gradient at a particular point is a number. You get it by putting that point's x into the rule. Those are 2 different objects, and a question about a line always wants the second one. Our curve is x cubed minus 3x squared plus 2x plus 4. Differentiating term by term gives 3x squared minus 6x plus 2. At x equals 2, that is 12 minus 12 plus 2. The gradient there is 2. Now the point itself. Put 2 into the curve, not into the derivative, and the height comes out as 4. 2 different substitutions into 2 different expressions. Swapping them over is the most common slip in this whole topic. Now assemble. Height minus 4 equals 2 times x minus 2. Tidy that up, and the tangent is y equals 2x. One honest note while it is on screen. A tangent touches the curve at the point. It is not promised to stay away from the curve everywhere else. This one comes back and crosses the curve again, over on the left, at x equals minus 1. That is allowed, and it is not a mistake. The normal is the line through the same point, at right angles to the tangent. Every textbook says its gradient is the negative reciprocal. Turn the fraction upside down and change the sign. So where does that come from? It is a quarter turn, and you can watch it happen. The tangent has gradient too, so its step triangle is 1 across and 2 up. Rotate that triangle a quarter turn about the point. The 1 across stands up. The 2 up lies down, and it lies down pointing the other way. Read the new triangle off the page. 2 across, 1 down. That gradient is minus a half. The rise and the run have traded places, and that is the reciprocal. One of them changed sign, and that is the minus. There is a neater way of saying the same thing. Multiply the 2 gradients together, and you always get minus 1. 2 times minus a half is minus 1. That is a check you can do in your head every single time. One case breaks the rule, and it is worth 30 seconds of your attention. If the tangent is horizontal, its gradient is 0, and turning 0 upside down is not allowed. Geometrically, nothing has gone wrong. The normal is simply vertical, and a vertical line has no gradient at all. So you write it as x equals the point's own x coordinate, and you move on. Here is the question, in the wording a real paper uses. The curve has equation y equals x cubed minus 3x squared plus 2x plus 4. The point on the curve has x coordinate 2. Find an equation of the normal to the curve at that point, giving your answer with whole number coefficients. 7 marks. Watch where they actually sit, because it is not where most people spend their time. Differentiate. 3x squared minus 6x plus 2. 2 marks, and that is the only calculus in the entire question. Substitute 2 into the derivative. The tangent gradient is 2, 1 mark. Substitute 2 into the curve. The height is 4, 1 mark, and that is the one people forget to collect. Flip it and change the sign. The normal gradient is minus a half, 1 mark. Point plus gradient. Height minus 4 equals minus a half times x minus 2, 1 mark. And the last mark is not mathematics at all. The question asked for whole numbers, so multiply everything by 2 and gather it onto one side. X plus 2y minus 10 equals 0. That final mark is given for the form. It is one of the most commonly dropped marks on the whole question, and nobody drops it because they cannot do calculus. Look at the split. 2 marks for the differentiating and 5 for everything around it. This topic is not really testing whether you can differentiate. It is testing whether you can finish. Before you move on, 3 checks. Between them, they catch almost every slip this topic produces. First, put the point back into the line you have just written down. 2 plus 2 times 4 minus 10. That is 2 plus 8 minus 10, which is 0. 0 is what the right-hand side says it should be, so the point really is on the line. If that does not come out, your arithmetic went wrong somewhere, and you have just found it for free. Second, multiply the 2 gradients together. 2 times minus a half is minus 1. If you do not get minus 1, you have not turned a right angle. This one catches the 2 commonest errors at once: forgetting to flip and flipping without the minus sign. Third, and it is the fastest of the 3, look at your sketch. A steep tangent has to have a shallow normal. An uphill tangent has to have a downhill normal. If you have written down 2 lines that both climb, one of them is wrong, and you can see that without doing any arithmetic at all. One honest word about that picture, because it matters more than it sounds. A right angle only looks like a right angle when one step across the page is drawn the same size as one step up it. Stretch the axes and a perfectly correct normal stops looking perpendicular. The mathematics has not changed, only the drawing has lied. The recipe, and it does not change from question to question. Find the height, differentiate, substitute for the gradient, flip it if they asked for the normal, point plus gradient, then read the question again and give the answer in the form it asked for. 3 traps. The first is the one we opened with, handing in the gradient when the question asked for a line. A single number is never the answer to the word equation. The second is leaving an x in your gradient. If the final line has an x sitting where a number should be, then the gradient function has been written into the line, and the result is not a straight line at all. The third is using the tangent's gradient for the normal, or flipping it and forgetting the sign. The second check catches both of those instantly. Multiply the 2 gradients and see whether you get minus 1. And keep the vertical case in your pocket. Horizontal tangent, vertical normal, and you write x equals a number. 1 point, 1 number, 1 line. Every question in this topic is that same move twice, once along the curve and once straight across it.